Okay, so we will continue our lecture in ggplot, and so for that we'll just take a look at some of the basics, the point, the line, and the bar geometries. There are many more geometric objects that I think somehow I clicked this too many times. You know, lots of geometries that you can add, and so definitely I recommend that you check out your ggplot 2 reference guide for other examples. But I think the bar, line, and point geometries cover a lot of your basic statistical graphics, right? And then if you want to try to get more complicated and more fancy than that, you know, then that's up to you, okay? Probably, you know, if you're going to compete in DataFest, you probably need something more than a bar graph or, you know, point scatterplot or something. You'll have to be a little bit more creative there, and perhaps maybe ggplot will not suffice. Maybe. I mean, as far as the data visualization, they're generally going for something innovative rather than you know, a standard bar graph. Okay. All right. Let's take a look here. So, you know, we'll talk about these basic things, but again, if you're trying to win a data visualization competition, generally those awards go for innovative graphs. Okay. But you definitely need to master the basics before you can get there. All right. Let's talk about bar graphs, okay? And so when you are plotting data for a bar graph and you want to prepare something, okay, there are a few ways it can be done, all right? So if you have data such that you have a column representing the x position of each bar, generally that will be categorical, such as like group 1, group 2, group 3. This is coming from the data PG_mean, and this is after loading up the graphics cookbook library. So if you look at the graphics cookbook library and then you ask for help on PG_mean, it is the mean results to an experiment on plant growth. Okay, so apparently if we look at the plant growth data set, you know, they've got different things, and these are just the means for the different factors that they have. Okay, and so to tell ggplot that the height of the bar that we want the height of the bar to be equal to the number that appears in this column, we use stat equals identity inside the argument for geom_bar. Okay. So we would say ggplot, we're going to take our data, we're mapping the grouping variable to the x-axis, so that separates them, so the three bars are not stacked on top of each other. And then the height of the bar is determined by the weight, except the weight value is being used to determine the height, so we say stat equals identity. And that's fine. All right, so this is kind of your basic bar plot. You want to create bars this height, you're going to use these values to determine their height. Okay, basic bar plot. If you have another variable to fill, we can. So here we have the cultivar and the date. Okay, and as far as dates go, we have D16 and D20 and D21. We've got 3 different dates, and as far as cultivar goes, we've got 2. C39 and C52, right? And so here we are going to use along the x-axis the date, so we will have the 3 dates, day 16, day 20, and day 21 going across the x-axis. The height of the bar that we're plotting is going to be this weight value, okay, and that's where stat identity comes in. And then we will have 2 colors as determined by fill equals cultivar. We're going to have a color for C39 and a color for C52, cultivar 39 and cultivar 52. Okay, because apparently we are looking at some cabbage data here. Okay, again, we can look at the help on cabbage exp, and it's just summary data from the cabbages data set, which itself is 60 observations from 4 different variables. A lot of statistics has its origin in agricultural studies, because this was a big thing. Yeah, question?
So we can actually fill the color of the graph, because actually the cultivar variable is actually a factor. So how can we specify what colors we want if this cultivar is actually a factor we assign?
Wait, okay, so cultivar is a factor, that's correct, and we're using cultivar as the variable that we are mapping to fill. So I'm sorry, your question is?
How do we, for example, how do we specify another color we want to use? We just change the factor level.
Like you want to use red and blue versus yellow and green?
Yeah, maybe.
Okay, yeah, that's in your scale. You can set those. You can set manual scaling, and I've got a slide for that. Okay. All right. So here, so the command here is we are looking at this data set, cabbage exp, or again, you can just pipe it in. You can take cabbage exp, pipe it into ggplot. You set the aesthetic mappings, as we said, and then we say stat equals identity because we want the height of the bar to be determined by the value in the weight column. And position equals dodge means don't stack the bars on top of each other, but put them side by side. And when we do that, this is what we get. And so here we have, I don't know what color you'd call this and what color you'd call this. On my screen, it looks like salmon and teal, if I had to use those words, but I don't know. On your screen, it looks a little bit like a deeper red, but what's that? Blood orange, okay. So we'll have this, and that's what we have. Okay. So in all of these things, the bar geometry has been used stat equals identity because the height of the bar is actually a value that appears in this column. Okay. When a lot of times when we look at data and we talk about creating a bar chart, then we might, what we're plotting might be summary counts, like a frequency variable here. Okay, so here we have this data set called diamonds, and diamonds has almost 54,000 rows in the thing, and we are looking at, we have a few different variables, right? And so I don't know if anybody has been in the market for diamonds, but what's that? A month of your tuition? They say, what is it, 3 months salary or I don't know, whatever. Okay, so $30, right? So diamonds are rated on different things, such as the cut and the clarity and the color and the carat. Those are your 4 C's of diamonds, which whatever, this is what we have. And we can pipe these things, such as the cut, which we have apparently fair, good, very good, premium, and ideal. Those things, we pipe them into here, and we just say that if we map x equal to cut, then geom bar, its default thing, we don't have stat equals identity or anything like that. It's going to go through all 54,000 rows and say how many good observations do I have, how many ideal observations do I have, and it will plot that accordingly. Diamonds are an interesting case study. They're intrinsically worthless or low value, but yet because of successful marketing campaigns, we've assigned great value to them. But just like everything else, right? Like the paper money intrinsically doesn't have much value, but because we've all accepted that it is valuable, it's valuable, right? So anyway, that's the default behavior for geom bar. So if you want to it's going to create basically a frequency table underneath it and plot the heights of those frequencies. If we want, we can map a variable to the fill, okay? So here we're going to look at this data table that has population change, and I forget what year it looks at, but we have U.S. pop change, and this was how much did the population of the state change between the 2000 and 2010 censuses, right? What's the plural of census? I don't know. Censuses. Censi? No, that doesn't make sense. That determines how many people get to vote in the House of Representatives and things like that, and all of that. And the 2020 census, it doesn't look good right now because the person who used to be in charge said, "I don't want this anymore." Well, anyway, all right. So we got here. We're just going to take the ones that have the top 10, so they rank above the other 40. Okay, and so these are the top 10, and the top 10 population changes in alphabetical order is this, and we can plot this, right? So if we want to plot this, we can say we're going to look at the state abbreviation. We're going to plot the change using identity as the height, and the region we will use for the fill, okay? And as far as the states that appeared, only states in the South and the West appeared in our top 10, and so we have those two colors, South and West, appearing here. Okay. If we mapped, so notice what I've changed here between this command and this command. The only thing was the variable that we mapped to fill, okay? So under the fill, we mapped the categorical variable region, so we get two colors, one for West and one for South. Over here, we mapped the numeric variable change to fill, okay? And so if we look at the data, change is numeric, and so it creates a scale. It looks at this and it says, okay, the smallest value I see is for South Carolina at 15.3. The largest value I see is Nevada with 35.1. And so it puts that on a scale where 15.3 is at the bottom and 35.1 is at the top. And its kind of default color scheme uses like a dark blue, almost a black here, and then a light blue for the bright. And so all of these things correspond to this. If we choose to reorder the bars, we can do that. So over here under X, we say use the abbreviation, and so it uses the values as they appear in the table, starting at Arizona, Colorado, Florida, ending up at Utah. Over here, we're going to say reorder. X is going to be the result of reordering the abbreviation based on the change. So this is going to take the abbreviation and reorder them using change to go from least to greatest. And so here we can see that the height of the bar corresponds directly to the shade of blue that is being used. Okay, so we can see that the shortest bar is the darkest, and as they get taller, they get lighter and lighter and lighter until we get to the tallest bar there. Okay, and so as far as the colors go, all we've done is we've mapped the continuous or numeric variable change to fill, and ggplot does this accordingly. Okay, so we don't have to come up with some kind of vector of shades of blue to use. The ggplot figures this out for us. Yes.
So for the command rank, does it go from the greatest to the least?
I'm sorry?
For the command rank in the previous one?
The command, which one?
Yeah, that one. Rank change rate.
The rank. Oh, so here, what it does is if we rank change, okay, it's going to say I think rank goes from the smallest to the largest. Okay, so the smallest one is going to be 1, and then the biggest one in this case would be 50. And so here we only want the ones where the rank is over 40. So that's going to be, 41 through 50. That's going to be the 10 largest. Okay, so this is what we have here. You can use custom colors if you want. So I don't know, was this your question that you had earlier about the custom colors?
Yeah, so the first question I'm wondering is, if the fill vector is a character, can we still do scale fill radius?
Can it be character? Yeah, so if it's character, then it's going to treat it basically as a factor. It's going to treat it as a categorical variable. Now, if you have like, if you have, if it's character and like, maybe you're looking at like tweets or something, it doesn't make sense to try to turn tweets into factors, right? Because you might, like, if you have 100 different observations, you're going to have 100 different character values. And how are you going to correspond the content of a tweet to a color? That you're not able to map that to a color, right? It makes sense to map categorical variables to colors, right? If you have 4 different categories, it makes sense to pick 4 colors and map each of those variables or categories to a color. That makes sense. But if you're taking, you're looking at data from a tweet or something, and you're trying to map the contents of the tweet to a color, that kind of correspondence doesn't make sense. Or is that what you were asking? Yeah. So if the character data can be turned into categories, then yes, we can do that, right? I don't know. Maybe if you want to say like, you're going to take your character data and be like names that start with, I don't know, names that end with N or something versus names that end with a vowel or names that end with Y or something like that. And you can say like, okay, we're going to do something like this, right? Or perhaps, I don't know, if you were looking at data from tweets, you can maybe somehow have a variable that corresponds to, like if you're looking at political figures, maybe you can have something that corresponds to like political party affiliation, and then you can map something to colors and say red represents Republican and blue represents Democrat. I don't know when that kind of became established, only very recently, like 2000. Prior to that, it wasn't like one side was red or one side is blue, but now it's very clearly associated with colors. So, yeah. All right. So, but anyway, you can pick custom colors here for the things. So, if you want blue and orange or blue and gold, or this is what we have. If you want to do the same for a continuous scale, so earlier we had this, and the default colors were from this dark blue to light blue. You could use a different thing and go from red to blue, and you'd get shades of purple in between. And if the data was more smooth, we would see an even smoother transition. But there is a pretty stark jump between the population gain in Arizona and Nevada, and so it seems to jump from this magenta to blue very quickly. But the command got cut off on the slide. But as far as the command goes, in the data. It's right here. Maybe I'll have to put this on the next slide right here. Next slide. Okay. Scale fill gradient, and you set the low and you set the high. Okay. And ggplot figures out the shades in between. And then if you do something, you know, like orange to blue, which are complementary colors, go back and run this. You know, it will figure out kind of the transition colors in between, and it you know, you just get different looking things, right? Okay, is that okay?
Can we customize each level?
Each level for a continuous scale?
Yeah.
Let's check the documentation, because how do you, yeah, there's tools. You say like color hex codes. So you can, yeah, exactly, HTML color codes. You know, I was looking at UCLA hex colors earlier, and we have a specific branding template here that says if you want official UCLA colors, these are the hex codes you're going to use. Did you know that? Right? So this is official UCLA blue and UCLA gold. But when I used this, it was like too bright for a bar chart, so I used the tertiary color. I don't know if that's allowed, but whatever. Okay, so anyway, you want to look up stuff like that, you can do that. Let's see, scale color gradient color scales, and you can have low and high, and color for the midpoint. You might be able to set 3, low, mid, high, but I don't know. Let's try it. Low is orange. Well, I don't know. We'll go from low is purple, mid is orange, and high is blue. Let's just see what this looks like. Oh, it doesn't like it. Scale fill gradient. I don't know, it doesn't like it. Purple to blue. Well, let's see. Low, mid, high. Scale fill gradient. I have to say gradient 2. That's what it is. Low, high. Let's just try it. I want to just see something crazy. Like, I know this breaks the rules of coloring. All right, let's just see. It doesn't like it. Let's try white. Okay, okay, I haven't figured it out. I'll have to play around with it. Sorry. Presentation ruined. Okay. Or more questions? Wait, scale, fill, color. What do I have written here? I've got scale, fill, gradient, and what were you asking about? Oh, that's a good question. I don't know. Scale star creates. Oh, I'm sorry. Okay, yeah. So when you're talking about bars, the fill is this, and technically, I think the color if we create it as a setting, I think the color is, there might be an outline. Color, we'll do black here. And it creates an outline of the bar. Okay, so that's the color. So fill is the shading that goes inside, and then generally color is turned off. But if you wanted to, you could have color of the line here, and you could have that color be something different and try to communicate another variable. Although, I don't, you know, at a certain point it just becomes too hard to process, right? Like this is a shaded purple bar with a white outline, that means this, and a shaded green bar with a red outline means something else. We lose a little bit of the our ability to process that much information all at once. Okay, let's take a look at line graphs. So basically line graphs are kind of like point graphs, except they're connected via lines, so you use them to communicate things that are joined together rather than individual things. And so here we are looking at this data set on BOD, and if I ask for help on BOD, it's biochemical oxygen demand, and we are looking at a numeric vector giving the time of the measurement in days and a numeric vector giving the biochemical oxygen demand, which is outside of my realm of expertise. So I'm not quite sure what any of this means, but this is what we have. We can just map the x, the time variable to the x position, the demand to the y position, and then this is our aesthetic mapping from variables to attributes of the graph, and then we just say we want line geometry being plotted. And ta-da, there you go, right? And now we can see, oh yeah, it was climbing up, and then there was a dip, and then it went back up. Okay. Great. If we wanted to draw multiple lines based on different categorical variable, that's definitely possible. Okay, so here, this is our summary table after we are looking at tooth growth data from guinea pigs who were given orange juice or vitamin C. Apparently, this may affect how much guinea pig teeth grows. I don't even know why they're called guinea pigs. They look like big rats without tails. Kind of, yeah, big hamsters. That's more appropriate. And so this is what we have. We've got 3 in the orange juice category, 3 in the vitamin C. These are the different dosages. As we increased the dosage, it does appear that tooth length grows. Okay, and so what do you know? More orange juice or more vitamin C, tooth growth does seem to increase, although orange juice seems to go higher. What's that? Yeah, we don't have units. I don't know. We measured them somehow on the same scale. I don't know what they are. Okay, so here we are taking the supplement type, this supplement category, and mapping that to color. So we get our 2 kind of default orange and blue colors, and they get mapped here. Of course, just like everything else, you can customize the colors and whatnot. As far as lines go, you can also have different line types. So you can have solid lines and dotted lines, and it defaults, if you give it 2, it will default to having a solid and a dotted line. If you have it 3, I forget what the third one appears, but it's like a different kind of dotting. And you can always specify that. And then if you had to, you could communicate 2 different types of variables, one for color and one for the line type. But we have that. Okay, so it's just, again, mapping some attribute of the data, in this case, the supplement type, to some graphic property. Okay. I don't know, what else would you do with a line? You can change, I guess, the thickness based on you might be able to plot the thickness based on a numeric attribute, although I'm not sure. I don't know if this would work. I don't think ggplot is capable of this. You guys know about the Napoleon, not dynamite, Napoleon data visualization. This is like the most famous data visualization of one of the in history. Are you guys familiar with this? You guys are not. This is okay. So you look at this. So this is very famous. All right. Oh, look, they turned it. It's so great. They turned it into a SVG, right? And you look at this and you're like, what is this even, right? This is a map. So I don't know, it's a world history or European history. Napoleon tried to invade Russia, and it didn't go well, right? So anyway, he started off over here. The thing is a map, and this is the path, the trail that his army took to get to Moscow, and the width of the line represents how many troops he had. Okay, and so in the beginning he started off very strong with many troops, and as they continued, you can see the line thickness dwindle until he reaches Moscow, and it's quite thin. And then the retreat is the black line going back. This is the path they go back. And yeah, okay, and we're getting an audible reaction, and you can see how when they return, the number of troops was much, much lower. Meanwhile, the graph also plots the temperature as they were going, okay, for the return, okay? So you can see that as they were returning, the temperature, it was getting colder and colder and colder, and that was, it was set. So anyway, this was, you should look up this little bit of history for data visualization as far as, what can be communicated in a single graph to kind of explain it. And I don't know, I don't think ggplot supports the ability to change the line width based on a numeric variable, but maybe it's possible, and maybe you could recreate something of the sort. But that's what we have. Okay. All right, and then lastly, we've got Scatterplot. So we are drawing dots, okay? And so here we're just looking at some height versus year, okay? So we can see that as these adolescents get older, from 12 to 14 to 16, and we look at their height, the height gets taller in general, but not in a linear fashion, kind of. But this is what we have. All right. We can try to, as settings, you can change different shapes. And so here we have not mapped a variable to the shape, but we have mapped we said we want shape equals 21. And you can always go and you're like, what are these shapes that are available? You can just go to plot shapes. And one of these things will have the different different shapes that you can plot and whatnot. Maybe, I don't know, ggplot shapes. Apparently you can plot letters and stuff also. Okay, so anyway, you have that as a setting. You can use change the size of the dots. So here the default dot size is this, but if you want big dots for whatever reason, you can say size equals 3. But again, if you wanted to, you could associate any of those attributes to a attribute of the data. So in this case, we can plot the sex, all right, and use that to plot different colors, and we can see in general, by around 16, there seems to be a differentiation between the heights of boys and girls, whereas at age 12, the heights of the boys and girls are very much mixed down here, okay? And so this is what we see. And again, if this is just the color, but if you can associate the shape if you want to use shape or size for something else, right? That could be done. So here, if you don't have a color printer, you can use triangles and circles, although it's a lot harder to parse, right? But it's possible. Okay, I think that was the last of the slides, but you know, let me just see if we can play around. Can you combine a line and a scatter? Yes, you can add lines to the scatter. And you can even take information from different data frames, but I don't know all the commands off the top of my head. So I would reference you to the graphics cookbook, which will probably have a recipe for doing something of the sort. But I don't know. Yeah, so in one of my other classes, we just did like some logistic regression stuff. And let's see if this plot has it. Well, I'll just knit it, I think. This will knit to a PDF. That's fine. So for, you guys have done logistic regression? No? Yes, you will? No, you'll probably cover it in your regression class. 101A, maybe? All right, well anyway, here. So here, you know, I create a scatter plot over here, and so this is age versus coronary heart disease, and the idea being communicated here is that as you get older, your risk of coronary heart disease increases. And here is, well, we're going to skip all of this, but you can fit a logistic regression curve to this, and I've added dots versus kind of the fitted path. The dots represent summaries. So because everything is they're individuals, you have to say, okay, for people in the 40 to 50 age group, what's the average, you know, what percentage of people experience coronary heart disease, and that's this dot represented here, okay? And then if you wanted to plot the original individual data points and stuff. So definitely you can mix the scatter plot and having a curve and things of that nature onto here. You know, all of this you figure out with just basically using the reference guides and the ggplot documentation and a combination of cookbook recipes to kind of figure out what you need. Okay, that's the only way you're going to get better at ggplot is by playing around with everything. So, okay, we'll end here for today, and we'll see you guys on Friday for the midterm exam. And good luck as you guys study. So see you then.